We're going to be talking about gas calculations. This is sort of part of the quantitative chemistry topic. We need to work out the number of moles of chemicals, either using mass that we've done so far, using the moles calculation we've done over the last few lessons, or we might work out moles of stuff using volume and concentration that will maybe start later today or move on next time, or we have to use gas volumes. Now the thing we need to know is that something called Avogadro's law, which is that, we don't need to know the name of it, but I'm going to tell you anyway. So Avogadro's law tells us that 1 mole of any gas has the same volume. It does assume that the temperature and pressure are fixed, but 1 mole of any gas has the same volume. Okay, and that's a really interesting kind of concept which isn't necessarily very obvious. So first of all, because I want you to understand this rather than just tell you the calculation, I want you to understand it. So if you just have eyes this way while I just walk you through why that kind of makes sense. I'm going to draw a couple of pictures to help with that, which you don't need to copy. The first of which is, you were taught in year 7 in your physics lessons, particles of gas look like that moving around a box, right? And that model is fine, and it helps you realise that there's space between the particles. They're moving around in straight lines, maybe bumping into the walls, causing pressure and all that kind of stuff. But in reality, it's got some problems. The main one of which is that in a gas, the particles of gas are actually completely and utterly tiny compared to the space they're in. There's far more empty space in a gas than you might realise if you use this kind of model of a gas. You okay with that? Yeah, makes sense so far? Yeah, so the gas particles are tiny. Now, if you take a gas, let's say hydrogen, which is a very small molecule, made of only 2 very tiny hydrogen atoms joined together with the formula mass of 2, let's say that's represented by those little tiny dots that I've drawn, and I do another one with the same number of gas particles, but this time it's, say, carbon dioxide, which are much bigger molecules. They've got 3 atoms, 3 much bigger atoms, and in total the formula mass is 44 for carbon dioxide. But those gas particles are ever so slightly bigger. But can you see that relative to the size of the box, the size of those molecules are negligible still? And so it doesn't matter what gas it is, the volume of the gas is the same regardless of what gas it is. And there's a value that's useful to you, which would always be given to you, which is the molar volume of a gas. So molar volume of a gas, and that is at a fixed temperature and pressure, which you'll learn a bit more about in year 12, but it's equal to 24 decimeters cubed, and a decimeter is 1,000 centimeters cubed, same as a litre, and so you need to be able to convert between decimeters and centimeters cubed. So decimeter and centimeters cubed are set out there. Okay, so that means we can link together the number of moles and the volume. So the volume of a gas in decimeters cubed. This is the same as it is on the sheets that you'll see on the video in a second as well. It's equal to 24 simply times the number of moles, or n times 24 if you prefer. Okay? Or if it's in centimeters cubed, it's simply 24,000 times moles. Okay, either of those, and you can all rearrange that. I'm not going to draw it as a triangle for you. You can rearrange that equation quite comfortably. So the kind of things you might have to do in a pretty simple question are on the worksheet that you've all got, and it will look something like this. And you'll see the equation you need is at the top. They're not rearranged, but let's rearrange it for you now, which is that we can work out the number of moles, n, being equal to the volume in decimeters cubed divided by 24. Okay, so that's just a rearrangement of that equation there. And you've got the conversion written up there as well. Okay, So when you're looking at these basic, very straightforward questions, it asks you to find out the volume from the number of moles. It doesn't matter what the substance is. All you've got to do is plug the numbers into the equation. So the volume is equal to 24 times the number of moles, which is given in the question 4. 24 times 4, 48, 96. And we always write the units, remember. Okay, that's it. Second question is exactly the same as that. The question C is a tiny bit harder. Lay it up a tiny bit, because you've first of all got to work out the number of moles by doing moles is equal to number of moles is equal to the mass over the formula mass, which for argon is atomic mass rather than formula mass, but it's the same thing. So mass is 15.0 divided by argon, which is 40. That gives you the number of moles, and then once you know the number of moles, you can multiply by 24 and away you go. I think you've got enough information there to work through the rest of the worksheet, but I'll come around and help you if you need any further help at all. Away you go. So well done on that first page. It looks pretty good that you've got the hang of that. In reality, the questions you're more likely to get than simply working out the volume from the number of moles or vice versa is a question like this. So can I just have all eyes this way? Even if you've not quite finished, you can catch up in a sec. So just catch up in a little moment if you need to. This is where it's at. This is where the questions are going to come from in this topic. Right, so it might be you're given some information in a question about a balanced equation, and in the end we have to work out the volume. And this seems to come up quite a lot, and it's usually worth a fair few marks. So there's quite a lot going on here. Now, if you stick to the method that I've been teaching, which is set out everything you know, and if we're not sure what to work out, we work out the number of moles, right? We should always work out the number of moles of things. So let's just do that. Set out the grid, and we just start writing down what we know. So let's always start with the molar ratio, so that we understand that they react in a 1 to 2 to 1 to 1 ratio. Always get into that habit, even if it's really obvious to you. Show the examiner you know what you're doing. And you're told in the question you've got 0.540 grams of calcium. So let's put that mass in here. 0.540. And if we know the mass, we can work out the moles of that. So the MR, which in this case is atomic mass because it's just one element. And calcium, if you look at the periodic table, is 40. So we work at the number of moles by doing mass over MR. And so 0.540 divided by 40 is 0.0135, and given I've got the answers in front of me, that's what I should have done. Let's look at those. Okay, anyway. And then it's asking you, find the volume of hydrogen gas. Okay, so that's the thing we need to find out, the volume of hydrogen gas. So really read the question carefully. If we know the number of moles of calcium, we can work out the number of moles of hydrogen gas, just like we did with the reacting mass calculations. Here it's nice and easy because they're a 1-to-1 ratio, so it's 0.0135 there as well. And by setting out like this, you're showing the examiner you know that and that are the same, and you could get marks for that. Often you'd have to multiply by 2 or divide by 2 or something like that, depending on what the ratio is. And then we're not trying to work out the mass, we're trying to work out the volume. We work out the volume using the molar volume, don't we? We know that 1 mole of gas has 24 decimeters cubed. And so all we've got to do is do the volume is equal to 24 times 0.0135, and that comes to, please, 0.324 decimeters cubed. Right, so we've got the idea there. There's a couple more questions on this page. I want you to do the same thing again, but just be particularly careful with question 6 because there's some more ratios there. We'll go through that one on the board in full in a short time, but away you go. So question 6 asks you to find the volume of carbon dioxide gas, assuming you've got 6 kilograms of ethane burning in oxygen. So first thing to remember to do, just like with all the reacting mass calculations, is convert to grams. We always need to work out the number of moles from grams divided by the formula mass. And remember, when we're working out the formula mass, we put a box around the chemical, working out the formula mass for, 0 times by 2. So 12 add 12 add 6 is 30. We get 200 moles, so 6,000 divided by 30 is 200 moles of ethane, so tick for that. We've been asked to work out the number of moles of carbon dioxide. It's a 2 to 4 ratio. To get from there to there, you times by 2. So 400 moles of carbon dioxide, so you get a mark for that. And then to work out the volume of gas, we don't need to work out the mass or anything like that, just the volume. So the volume is equal to the number of moles times 24, which is equal to 24 times 400, and that comes to 9,600. Never forget the units, please, folks. And that's how you do those gas calculations. They come up quite a lot on one of the weakest scoring parts of the test. And I've got some practice questions that I'll share with you as well.